Hello and welcome back to Algebra 1 with Mr. Farina. Today our main focus is going to be on factoring quadratic trinomials when a is not equal to 1. Okay, it's a little bit different than what we did yesterday, but if you understand the steps, it's actually not that hard. In order to do this, we'll focus on two things. First, we're going to talk about how we factor by grouping. And then once we factor by grouping, then we'll be able to use what we refer to as the AC method to factor ax squared plus bx plus c when a is not equal to 1. Now looking at factoring by grouping, if I gave you the expression 4x squared times x minus 2 minus 3 times x minus 2, I know I can go ahead and simplify this expression by, distributing. When I distribute it to 4x squared, I get 4x to the third minus 8x squared. When I distribute that negative 3, I end up with minus 3x plus 6. Okay, but our goal with factoring by grouping, okay, is actually to work from here back to this. Now we will take it a step further later on, but going from this polynomial expression to this factored form is the hardest part. Now, factoring by grouping, okay, when we factor by grouping, one key thing you need to know is you pretty much do it, you only use it when you have at least 4 terms. Okay, that's a key indicator. This right here is a key indicator that tells you that you are going to factor by grouping. Okay, now how do we actually do this? Well, the first thing that we do when we factor by grouping is we group the first 2 terms and the last 2 terms. Okay, once we group those, what we're going to do is we are going to factor out the GCF from each binomial grouping. Okay, now once we do that, okay, then we're going to go ahead and factor out the greatest, and this is key, greatest common binomial factor. Okay, now this will be easier to see throughout an example. Okay, but if we wanted to go from here to here, how can we do it? Well, if I factor those 2 terms together and these 2 terms together, group them together. Okay, I look at 4 and 8 and I say, what's the greatest common factor between those? Well, 4. If I have x to the third and x squared, I always take the lowest exponent. And how do I determine what goes into parentheses? I divide each term by 4x squared. 4 divided by 4 is 1. X to the third divided by x to the second is x minus 2. Now, when I look at these 2 terms, the greatest common factor is going to be a little different. I'm going to actually factor out a negative 3. Now, the reason I factor out a negative 3 is I never want this leading term here to be negative. So to make it positive, I factor out the negative. So, negative 3x divided by negative 3 is positive x. 6 divided by negative 3 is minus 2. And if you look, this binomial factor and this binomial factor is the same. Now, if we truly wanted to take it to the next level, okay, let's kind of go up here and just do a quick example. If I gave you guys 3x squared plus, 6, if I wanted to factor the GCF out here, I would pull the 3 out, and then I would divide each term by 3. And I'd have x squared plus 2 left over. If we wanted to factor this, we ask ourselves, what is the greatest common factor here? What do they both have in common? Well, they actually have the x minus 2 in common. So that actually acts as our greatest common factor. Well, how do I figure out what goes in the leftover polynomial? I divide by the x minus 2, those eliminate, and I'm left with 4x squared. Divide this by x minus 2, those cancel out, and I'm left with negative 3. Now, technically, although this looks different from what we started with, but truly it is the completely factored form for that polynomial. So, let's look down below at some examples here. Now, if I wanted to completely factor this, notice they've already grouped and factored the GCF out of each binomial expression. So the only thing we have to do is find what is our greatest common binomial factor. Okay, and I know we changed it a little bit, but I want you guys to see that both of these terms, this is one term, this is another term. What do they have in common? They have an x minus 3 in common. I'm going to pull that x minus 3 out. Then I'm going to go ahead and divide each of these by x minus 3. What happens to those? They cancel out, and what am I left with? 4x. When I divide x minus 3 here, those cancel out. What am I left with? Minus 2. And this would be the factored form there. Now, to step it up a tad bit, okay, how would we factor this? I look at it and I see 4 terms. As soon as I see 4 terms, 1, 2, 3, 4, I know right away I'm going to be grouping. So what I do is I group the first 2 terms and then the last 2 terms. I'm going to look at these 2. Once I group them, I have 2 terms here. So I have a binomial and a binomial. Now, looking at this, what is the greatest common factor here? Well, the GCF here is 2x, or just x squared. If I look, 2 and 3 don't have a common factor, but I have 3x's here, 2x's here, so I'm going to pull out x squared. Now, when I divide each of those terms by x squared, I end up with 2x minus 3. Now, if I look at the second set of groupings, this here, my GCF here is going to be the common factor between 4 and 6 is 2. They both do not have an x, so it's just going to be 2. So I'm going to pull out that plus 2, okay, and when I divide each of these by 2, I end up with 2x minus 3. If you factor by grouping properly, you will notice that the 2 binomials should be the same. Okay, so when I factor out that common binomial, 2x minus 3, then when I divide by 2x minus 3, I'm left with x squared plus 2. And this is what we get when we factor the given polynomial. Now, you're probably asking, why do we need to know this? Well, it kind of helps us in the next type of factoring. And that is actually the key concept for today. And that's using the AC method. Okay. Now, the AC method, when do we use it? We use it when you have a quadratic trinomial, ax squared plus bx plus c, and a is not equal to 1. Okay. Now, what do I mean by that? Well, if I look at this first example down below, okay, example 1, notice here how the leading coefficient is 5. That makes it more difficult to factor because before we were able just to put, say, w here and w here, and that gives us w squared. But now we don't need it to just be w squared, we need it to be 5w squared, and when we go to do our distributions, it actually messes it all up. Okay, now if we wanted to factor, say, let's just go with the 5w squared minus 6w plus 1. If I wanted to factor this, okay, I could use a trial and error method where I basically take the factors of 5s and the factors of 1, and I basically say my first terms have to multiply to give me 5w squared. My last terms have to multiply to give me 1. Okay, now when I look at it, if I say I put minus 1 here and minus 1 here, okay, now I know when I distribute, I should get what I started with, 5w squared minus 5w minus w plus 1, and if you notice, I get what I started with, minus 6w plus 1. Now this is kind of one of those easier problems because the first and last term, right, they're prime numbers. That makes it a little easier. So, looking at it, if we didn't want to use trial and error, what could we use? Well, what we use is called the AC method. Okay? Now, in the AC method, the first thing we do is, 1, we multiply the A and the C. Now, our goal in step 2 is to find the factors of AC. When you say factors, you mean multiply. The factors of AC that add up to B. So we're looking for the numbers that multiply to give us AC. So say those numbers are P and Q. Okay, then we need those numbers to add up to B. So we need P and Q to also add up to B. Once we find these numbers, we're going to break up this quadratic trinomial. Okay, and we're going to basically rewrite the polynomial with bx as a sum with the factors of AC. Now, what do I mean by that? Well, if we said our factors are P and Q, we're going to rewrite this polynomial as ax squared plus P times x plus Q times x. Okay, and then we're going to write our plus C. Okay, now once you have this done, your last step is to just factor by grouping. Okay? So, let's take a couple of examples here. Take a minute to write that down. Actually, probably best to pause and write it down. Okay, and when we go down to the examples below, the first one we have 5w squared minus 6w plus 1. Now here, when I multiply AC, A times C, what is 5 times 1? That's 5. We need to find the numbers that multiply to give us AC, which is 5, and add up to B, which is negative 6. Okay, now what numbers can you think of here? Okay, well, there's only one set of numbers that truly multiply to give you 5. Because we have to multiply to get a positive and add up to a negative, you should know our signs have to be the same. So negative 5 times negative 1 and negative 5 plus negative 1 satisfy both of these. Okay, now we're going to break this up or rewrite this polynomial as 5w squared. Now we're going to accompany this negative 5 and this negative 1 with x. We're going to rewrite this as minus 5x minus 1x, and then bring our plus 1 down. Next, the last step is to just factor by grouping. Group the first two terms, the last two terms. What is the greatest common factor between 5w squared and negative 5x? Well, that would be, oops, this is actually w's, sorry. w's and w's. So, factor out the 5w in the first one, 5w, and when I divide by 5w, I end up with 5w times w minus 1. Then I'm going to factor out a negative 1 here. So negative 1, and I end up with positive w, alright, minus 1. Notice how my two binomials are the same. That tells me I did this right. Well, what's the greatest common factor for the binomials? Oh, w minus 1 times. When I divide by w minus 1, bye-bye. 5w, divide by w minus 1, bye-bye, minus 1. And this is the factored form for our original polynomial. Now, if I were to multiply, how do I check this? How do I check to make sure I'm right? Well, if I multiply this out, w times 5w, 5w squared, minus 1 times w is 1w, minus 5w, plus 1. If I combine like terms, I end up with what I started with. And there is example 1. Okay, let's look at another example. Okay, now here AC is going to be 3 times negative 14, okay, which is going to give you negative 42. We need to find the numbers that multiply to give us negative 42 and add up to positive 1. Obviously, you know, because we're multiplying to get a negative, we have different numbers. And since we're adding up to positive 1, our bigger number needs to be positive. So, let's look at the factors 7 times negative 6. That gives us negative 42, and 7 plus negative 6 would equal positive 1. So the factors we're going to use are 7 and negative 6. So, I'm going to put z's with these two factors. I'm going to rewrite this polynomial now as 3z squared plus 7z minus 6z, and then my minus 14. Once I do this, I basically go ahead and factor the greatest, or factor by grouping. So, greatest common factor between 3z squared and 7z, well, that would be z times, divide by z, get 3z plus 7. Here, because this is negative, I know I have to factor out the negative. So, look, the common factor between 6 and 14 is negative 2. When I divide these by negative 2, you get positive 3z plus negative 14 divided by negative 2 is positive 7. And if you look, do our binomial factors match up? Yes. So, we factor out the 3z plus 7. And how do I know what goes in my leftover polynomial? Well, when I divide by 3z plus 7, bye-bye, I have z left over. Divide by 3z plus 7, bye-bye, minus 2. And we are done. Okay. Now again, you can do the trial and error method where you try to find the numbers, the first two terms and the last two terms, and see if you can, guess and check. But sometimes if you're not good with your multiplication tables and stuff like that, Sometimes it's just easy to use a step-by-step approach to these. So let's look at this last example before you guys go off and try your practice problems. Okay, so I look, AC here is going to be 2 times -3, -6, and what we have to do is find the numbers that multiply to give us -6 and add up to give us -5. So what numbers do this? Okay, well, if you think about it, your signs have to be different, and when you add them together it has to add up to a negative. So you're most likely, we say we're adding the two numbers, but since they're different signs, we're truly subtracting them. So what numbers multiply to give us -6 and add up to -5? How about -6 times +1? Because -6 plus 1 gives me -5. So if these are our factors, we're going to put our variable h with them, h and h. Okay, and now we're going to rewrite our polynomial. 2h squared minus 6h plus 1h minus 3. So basically we rewrote this -5h using these factors, -6 and 1, as -6h plus 1h. Now I can go ahead and group the first two terms, group the last two terms. Now I look here, greatest common factor, 2h. When I divide by 2h, I get h minus 3. Now I really don't have something to factor out here, but when we factor by grouping, you have to factor something out. And the one thing you can always factor out is going to be a 1. So I'm going to factor out a 1 here, and when I divide by the 1, sorry, that should be +1, okay, I still end up with h minus 3. And again, notice, are my binomial factors the same? Yep. So I'm going to factor out those binomial factors. Okay, and what do I have left over here? 2h. What do I have left over here? +1. And this is a factored form for 2h squared minus 5h minus 3. Okay, now being able to do this is probably the hardest thing in the chapter, but it is the most important. It's going to lead to solving quadratics by factoring, and later when we graph parabolas, we're going to basically be looking for the zeros using the factoring method. I hope you enjoyed the lesson, and it is your time to go ahead and work on the practice problems.